This video is to help with assignment 4.1, solving systems by graphing. With these, this first one, you need to be able to identify what each type of graph is, and how many solutions it has. So if we use our notes, we see that we have two lines graphed in that first graph. I only see one line. Well, that tells us that, in fact, we have the same line. And if we have two lines that are exactly the same, that is consistent and dependent. Right there. Okay, if it's two lines that meet at one point, it's consistent and independent. And if it's two parallel lines, it's inconsistent, I guess. Now with this, this is the part that's most important. When we have two lines that are exactly the same, that means every single point on those lines are the solution. So that means there's infinite many solutions. Okay, if we look at the next one, we have two lines that are perfectly parallel, and we can tell they're parallel by the slope is the same. If they're parallel, then that means they're inconsistent. Okay, again, inconsistent is parallel. Consistent and independent are when two lines come together at one point, and consistent and dependent is when they're the same line, and you only basically have one line. When they're parallel, they never ever cross. That means that they have no solution. And here we have two lines that cross at one point. That makes them consistent and independent. And again, inconsistent means they're parallel. Consistent dependent means they're the same line. The way I remembered it is one line depends on the other. That's because they're the same line. Independent, I can move one of the lines around and they're still only going to meet at one spot. Inconsistent means they're never ever going to meet. So when they meet at one point, that means they have a unique solution. Well, what is that solution? In this case, it's right at 0, 0. Wherever the point is that they come together, that is your solution. Number 2 is the same type of question. Inconsistent is when they're parallel. And if they're parallel, they never come together, so they have no solution. When they meet at one spot, you can still move one of the lines around and they're still only going to meet at one spot, so they're independent. And they do have a unique solution. A unique solution just means one answer, and that's that one right there where the two lines come together. So that's 1, -3. Your answer is just the coordinate or the ordered pair for where they come together. X is 1, Y is -3. Now when it's the same line, and if we solve both of those, we'd see it's exactly the same line, but we're also labeled here, line 1, line 2. Then one line is dependent on the other line, because if you move one line, you have to move the other line because they're the same. And they have infinite solutions. Every single spot on that line, no matter how microscopic, is a solution. So that's how you do number 1 and 2. Number 3, all you need to do here is graph the system. By graphing the system, we see this first one is already in slope-intercept form. So where's my y-intercept? My y-intercept is right here at 1, so I'm going to put my first point at 1. And then from there, my slope is up 1 over 2. So from here, up 1 over 2. If you remember, it's rise over run. Now this one, we can do it two ways. We can solve for y. We have 2x plus y equals -4. And we can just do the opposite of x, 2x, -2x. And we have y equals -2x minus 4. This side over here, you never ever combine them. They just stay separate and the x's come first. Okay, so with that in mind, we can say, hey, we've got my y-intercept at -4, and it goes down 2 and over 1. Down 2 and over 1. And that's where the second one goes. The other way to do it is we could do the cover-up method. We could say, all right, we're trying to find y-intercept. -4 divided by what's in front of the y? It's a 1. So -4 divided by 1 is -4. So my y-intercept is -4. Now with that same idea, -4 divided by 2. Why am I dividing by 2? Because now I'm looking for the x-intercept. -4 divided by 2 is -2. And so that's where it crosses the x-axis. So you can use either one of those methods. They both give you the exact same line. And if we look, it crosses right here at -2, 0. So our solution is -2, 0. X first. Remember that. X, comma, y. Okay. Number 4, same thing. Okay. Let's start by just looking at the first one. We have our y-intercept. Y-intercept is -1. And from there, we're going to go down 1 and over 2. Down 1, +2. And there's my line. Okay, I'm going to do the cover-up method first. 2 divided by 1, so the y-intercept is 2. And 2 divided by 2 for my x-intercept. X-intercept is 1. Okay, or I could solve it and just say, all right, 2x plus y equals 2. Solve for y by doing the opposite of x. And we have y equals -2x and +2. And either way, you get the same answer. So if I have a y-intercept of 2 and it goes down 2 and over 1, we see that 2 and 1 are my y-intercepts and x-intercepts. Okay, so that turned out the same. And we can see they cross right here where x is 2, y is -2. X is 2, y is -2. So they do have one solution. X is 2, y is -2. Always x, comma, y. X first. And the last one's going to be exactly the same. Okay, I'll go ahead and solve this one right now. So -2x plus y equals -4. And we're going to add 2x to both sides. And that gives me y equals 2x and -4. Or I could have done the cover-up method here and just figured out that the y-intercept is -4. And because that's -4 divided by the 1 in front of the y, -4 divided by the -2 in front of the x is a +2. So that gives me that one. So now I can graph, excuse me, now I can graph both of those. My y-intercept for the first one is +2, and then I go up 1 over 2. There's my line. Up 1 over 2, rise over run. How far you go up, how far you go over. Now this one, I have a y-intercept of -4 and an x-intercept of 2, so right there. Or I could have gone -4 up 2 over 1, and that would have been right there. So it would have been the exact same line. Now where does it look like they come together? X is 4, y is 4. So it looks like they have one solution in this case. X is 4, Y is 4. And that's how you do the assignment. Hopefully it's not too hard. It's meant to be a simple assignment just to get you practicing. If you have any questions, let me know.